video, I'm going to talk to you about proof of work and proof of stake, which are two different protocols on blockchain. So in the last video, we have established few facts. Let me walk you through one more time. So a blockchain is a connection or a network of computers known as nodes that sit across and work together as peer-to-peer. There is no centralized server. Every node has its own copy of the entire ledger so that it cannot be muted. It's immutable. It cannot be forged. That is the basic concept of blockchain. Please look at my previous video to understand what is a blockchain and what are different characteristics of blockchain. In this video, let's talk about proof of work. So, number one, proof of work is a protocol by which a transaction is processed on a chain. Proof of stake is another different type of a protocol that is used to process transaction on a blockchain decentralized network. So let's talk about proof of work. So imagine that these nodes belong to our friends Elon, Bill, and Jeff. Please note that there is no connection to Elon Musk, Bill Gates, or Jeff Bezos. It's all coincidental. Now, the nodes of a proof of work network like Bitcoin or Ethereum before September 2022, they were known as miners. So Elon is miner 1, miner 2, and miner 3 are Bill and Jeff, respectively. Now, when a transaction is submitted to the network to process a decentralized network, like for example, you are sending money from one person to other or doing some kind of a supply chain or executing different contracts, we'll talk about that later, you would submit data, and nonce is a number attached to the transaction. So very simple data, 5 diamonds, nonce 121. Now what will happen is all of the miners would compete in proof of work protocol to solve a cryptographic puzzle. So let me reiterate it. So when a user requests a transaction to run a data transaction, the transaction is sent to the network. The hash value needs to be created. So miners are running together in parallel to solve the hash, the cryptographic puzzle. They are competing with each other. The miners, whoever solves the first, it creates a block. So the miners, for example, in this case, miner 1, who has a better computational power, higher grade of node, this node would solve this cryptographic puzzle to get hash faster. So a miner using this data and nonce solves the cryptographic puzzle to form a hash. The higher the computational power, the better or the faster the miner is expected to solve that puzzle. Now, it's very simple. The cryptographic puzzle solved by the miner is asymmetric. It's moderately hard for the miner, but the other nodes in the network can very easily see the evidence of the massive number of crunching that this miner 1 is doing on the computer. Therefore, the computational power plays a major role in proof of work. Now, once the successful miner solves the mathematical puzzle, it announces the last recorded block on the network so that the other nodes can verify. This creates a block. So the miner who gets to mine this block first gets the block as well as transaction fee in the native currency. So for example, if this miner is on Bitcoin network, the miner is going to get the block and the Bitcoin for every successful transaction mined. So imagine this: a miner gets a transaction fee as well as the block in the Bitcoin currency, which is a native to Bitcoin network, or Ethereum or Ether for the Ethereum network. So let's summarize this proof of work. Miners solve a cryptographic puzzle. So all of the miners work together. That means all of these miners are using their network electricity to solve a cryptographic puzzle. That means finding the hash. This block is linked to the previous block using the previous hash here. Look at my previous video that talks about how these blocks are chained together. Next, a successful miner is the one who beats the other to find the hash of the last recorded block. A reward is in terms of block rewards and the transaction fees. The miner announces the block onto the network for other nodes to verify the block. And then Bitcoin and Ethereum, Bitcoin and Ethereum before 2022 used this protocol. Now let's look at the proof of stake. So one of the major problems with proof of work is that if one transaction comes in, all of the nodes are competing against each other. So really, it's a network, but each node is competing with one another in the network, and that makes this protocol a little difficult to scale. And that is where many government agencies are against this protocol because it leads to a wastage of electricity and the resources. Like miner one who wants to solve or hits the mining first, finds the puzzle, cryptographic puzzle solution first. That means the time, energy, and resources wasted by miner 2 and 3 gets nothing. So you might be on the network and end up getting nothing out of it. Let's look at proof of stake. Proof of stake protocol takes everything away from the mining perspective. That means there is no mining. In proof of work, the same concept exists. However, these earlier called miners are now takers. What really happens in proof of stake is each of the network nodes take currencies. That means put in their own currency, their own cryptocurrencies for validating the transaction. These are not known as takers. So for example, Elon has taken 10% of ether to the network. Bill has taken 9% of ether in the network, and Jeff has taken 7% of ethers onto the network. That means the chances of Elon to be selected as a staker for a transaction is high. Now let's look at it one more time. In case of proof of stake algorithm, a set of nodes decide to stake their own cryptocurrencies for validating a transaction. There is no mining. These nodes are known as stakers. The larger the amount of stake, the better the chances of a staker to get transaction validation responsibility. So what happens is when data is supplied or data is sent to the network for processing, from this validator pool, the staking pool, randomly a staker is selected. That means randomly a node is selected to validate the transaction. There is only one staker selected. In this case, Bill Gates was selected. Now, all other stakers are sitting idle. However, staker 2, who was picked randomly, now has the responsibility to validate the transaction. The transaction validation process is known as forging. In this, when a block is created with this hash, validated with, there is no new block, there is no new coin minted, a block is created with the hash and previous hash connection as in the proof of work. Please note that the successful validator, because Taker 2 was the only validator, there was no competition per se. These nodes or stakers were not competing against each other. The reward for this taker is the transaction fee, which is in the native currency. So, for example, Ethereum network uses proof of stake after September 2022, and therefore they only get the transaction fee as Ether. Please note that most of the cloud companies as well, they have banned using proof of work because it uses a lot of energy and resources for wastage as well. In most of the cases, they allow proof of stake in this case because it is related to the staking. There is no competition between the nodes. Now, let's look at the characteristics of proof of stake. Stakers take their own currency for validation of a transaction. So whoever is picked, they validate the transaction. Next, successful validator is the one who is randomly selected from the validator pool. That person has to validate the transaction. Rewards are only in the form of a transaction fee. Computational power is replaced by staking power. And Ethereum after September 22 and other newer chains like Solana use this protocol. Now, because the computational power is no longer a, a matter here, it is all about taking. The proof of work is not energy efficient and has a massive energy consumption. However, proof of stake offers low to moderate energy consumption. Now, one interesting thing is in proof of work, if I have huge computation power and I can beat all other nodes, I can I can really hack the network. But 51%, and those are known as 51% attacks. So 51% attacks are virtually impossible in proof of stake because it depends on the validator who is validating the transaction. It's not about the computational power. So I hope this was informational, and please keep watching.